Good afternoon and welcome to my video blog, OpenShift Outdoors. This is going to be a short episode today. I'm going to show you something that I recently worked up in OpenShift Dev Spaces while I was working with some folks that had an interesting challenge. So they are UI UX developers that are using OpenShift Dev Spaces as their cloud IDE, and in doing so, they needed to implement the test frameworks and the test harnesses that they're used to using on their local workstation. Well, those test frameworks and those test harnesses require a browser, which is not something that you generally think of running inside of a container. So what I worked up is a quick demo to show how, in a pinch, if you need to, you can actually run a full browser like Google Chrome inside of an OpenShift Dev Spaces workspace. So what I'm going to show you here real fast is Containerized Chrome. And I'm going to just walk through the demo real quick, and then I'll circle back and I'll show you how I put this together, because while it took me a while to find all the pieces to make this work, at the end of the day, it actually wasn't that difficult. So let me flip over to my task manager here and show you that I've got a Start Chrome task, which I'm going to click on here in a minute. And in this project, which I'll share the GitHub link in this video, in the metadata, I have a very simple, very stupid, just plain bootstrapped up Angular UI app. Why? Because I am not a UI UX developer, and I won't attempt to be. But I do know just enough TypeScript and just enough Angular to hack something together for demo purposes. So I'm going to do an npm install to make sure all my packages are up to date, and then I'm going to do an ng serve to start this UI in live developer mode. Now, I don't have any of the test frameworks that you might be using here. So I'm not going to be directly demonstrating that. There's more work to do to wire your test harnesses and everything into this browser once it's there. But this should get you the 85% of the way that you need for those of you who do actually know how to use these test frameworks. So my Angular app is starting up now. You see it's listening on localhost 4200. And I do not have port 4200 exposed from my workspace as an OpenShift route. So I can't, from the Safari browser on my workstation, I can't get to this Angular app that's running now. I mean, not only do I not have the route exposed for port 4200, but as you can see, because I didn't change any of the configuration, this is listening on localhost. So even if I had created a route, there's no service to connect to it to give me ingress to hit that endpoint. So at this point, I have a web application that nobody can get to, which is fairly useless. So let's go back over to the task manager, and I'll start up my Chrome service. And you see it generated this password here for me. I'll show you why I'm doing that here in a minute. And then this little pop-up came over here that told me that Tiger VNC, that might give you a hint, is now listening on port 6080. Do I want to open it? I could click this right here, but if I don't click it quickly enough, it will disappear on me. Never fear, however, because I can still get to my endpoints from the left-hand navigation. So I'm going to open this route now, which is exposed out of OpenShift, so that I can get to the VNC server that is serving up the display for my Chrome browser. And that's effectively what's going on here. So I gave you more than just a couple of hints. I'm using VNC to provide the X11 display. Chrome is attaching to the X11 display. And then I'm using this application called NoVNC that provides a JavaScript proxy to access a VNC client through a browser. So from my Safari browser, I'm hitting the no VNC endpoint that is giving me access to this Chrome browser running in the container. And you can see that if I put in a URL, it is a real browser. It is able to browse the internet because I don't have my OpenShift cluster disconnected from the internet. So I am able to get to at least things that my firewall would allow me to get to. I can also, and more importantly, I can go to localhost port 4200, and there's my Angular app. And just to prove that I'm not pulling a fast one here, I'm going to stop my app that's running in live dev mode and demonstrate to you that I did in fact lose the connection to it from my Chrome browser. And if I start it back up, the connection is restored. So there we go. I have a Chrome browser running in a container that's in my workspace. Now, how did I make this happen? Let me show you real quick. This is in my cgroover GitHub account. If you go to the repositories, it's the Dev Spaces Chrome sidecar project, which gives you a hint of how I've implemented this. The reason I put this in a sidecar in my workspace, and I'll show you the dev file here in just a second, isn't because that's necessarily the best way to implement this. In fact, if I were doing this for real, I would probably embed this in the same container that I'm hosting all of my developer tooling, my Java JDK, my Quarkus framework, my Node.js installation, and my Angular framework, and all of the build tooling and everything associated with it. I would probably cram this into there as well, because there really is no reason to run it as a sidecar. I did this so that if anybody finds it useful, they don't have to wade through all of the other tooling and stuff that I've installed in my workspace to find the bits and pieces to make this work. So if you go to the Chrome sidecar image folder, you'll find the container file that I use. You'll see I'm building this using UBI 9, grabbing the latest patched release of UBI 9, which is a RHEL 9 based image. I'm adding a repo to the repos.d directory. I'll show you what that looks like. That's simply so I can install Chrome from official Chrome. There it is, dl.google.com. The other thing that's going on here in this container file is I need the EPEL release for RHEL 9. And some of these packages that I'm installing, like Tiger VNC and No VNC, some of these also require subscription entitlements. Never fear, because you can access those entitlements. I give you instructions here in the README for the container file. There is a secret in your OpenShift cluster, as long as this isn't an OKD cluster. If this is an OpenShift cluster, even if you're using a free developer.com, Red Hat, developers.redhat.com account, which I encourage you to sign up for. There's tons of nice free stuff there. You can build an OpenShift cluster using temporary keys, and that will have in it the subscriptions. It's in a secret called etcpki entitlement that is in the OpenShift config managed namespace. If I pop over to the console of my cluster real quick and I browse the secrets in the OpenShift config managed namespace, there it is right there. And so those two values, entitlement key and entitlement, they're PEM files. You need those two files. And when you run your Podman build, you just include the directory that you dump those two files in as a volume to your container while it's building. Doing it this way means that you don't have to copy the files into the container and then delete them during the build, because you probably don't want to embed those in the container unless you want to share your entitlement secrets with the world. So doing it this way as a volume makes it ephemeral through the build process. The $Z is an SE Linux thing that ensures that the permissions are set correctly inside of the container so that the build process can properly read those files. So that's effectively how this is built. The way it's run, if I pop back over to the workspace, there's this Chrome utils shell script that I wrote, which also could be embedded in your container image. I left it out. I put it in the workspace mainly because it was easier to edit and debug that way. So in the future, I might cram it inside of the container image so that it's there as an executable inside. But what it's doing, and this will show you that password thing. I just have a cheesy little function that generates a random string of 10 characters that I write to a file. Actually, I write it to two different files. I'm using VNC password to create a binary of it that the VNC server can interpret, and that's going to temp VNC password. And then I'm echoing the value of that to temp VNC sec, just so I can retrieve it later. This is done every time I start this process, so it regenerates a new random password. It's a fairly simple mechanism that ensures that this VNC server and the associated client, the no VNC client, isn't just listening with no authentication whatsoever, so that you can add a layer of security to this. But I start the XVNC client or the server rather list to serve up display 0. I set its geometry and its color depth and some other things on it. Here's where I tell it to use VNC auth security type with the password file. Then I launch Google Chrome and bind it to that display. Then I launch the no VNC server, instructing it to listen on port 6080, which is what I have exposed as an OpenShift route declared in my dev file for the workspace. It is then binding to port 5900 on the local host in the container, which is where the VNC server is listening for client connections. So it's pretty straightforward. 3 pieces: VNC server to provide the X11 display, Google Chrome because I need a browser, and the no VNC server to act as an external proxy to allow the browser on my local workstation to connect to that VNC server as a client. And that's it. So with that, I can run Chrome as a full browser to either access things that I'm running in my workspace that I don't want to expose via OpenShift routes, or more importantly, so that I can use test frameworks that require a browser where I don't want to necessarily use a headless instance of the browser, but need a fully functioning, fully capable, bound to an X11 display browser. Last thing I'll show you here real quick is the dev file where I've declared this container, the Chrome sidecar container image, to run as a sidecar in my workspace, and exposing the port for no VNC. I called it Tiger VNC here because that's the server on the other side, on port 6080, so that OpenShift route is now available and exposed as an endpoint that I can connect to right here. So there we have it. I hope that you find this useful, and I'll see you again sometime soon.